This lecture video is about graphing linear functions. So the slope of a line is going to be an important thing in this, and so the slope is always denoted with an m, and the equation for the slope is y2 minus y1 over x2 minus x1, and this is the slope of the line that passes through the points x1, y1 and x2, y2. We can also think about the slope as rise over run, which is what we're going to want to do when we're talking about this video, or the change in y divided by the change in x. In this notation, the triangles just mean change in. So this means exactly change in y divided by change in x. Standard form of a line we're not going to see in this video, but I just wanted you to see it. And it's ax plus by equals c, where a, b, and c are all integers. So a, b, and c have to be nice, pretty numbers with no fractions. And x and y are on one side and the plain old number on the other side. Point slope form, this also we're not going to get into in this video, so we're just going to skip over that one for right now. Slope intercept form is the one that we're going to be looking at in this particular video, and so this will be really important. When a line is being written as a function, it's always going to be in slope-intercept form. And remember, f of x is the same as our old y, and so this really says y equals mx plus b. But we're using function notation, so it's f of x equals mx plus b. M is our slope from up above, so this was the other important equation for this particular video. And b is the y-intercept, which is where it's crossing the y-axis. So let's take a look at how to graph some linear functions. And again, they're functions, and so they're always going to be in this slope-intercept form. So our first example, we have f of x equals 3/2 over x. And so our slope m is 3/2. And remember, slope can be thought of as rise over run. And so our rise is 3. And our run is 2. And b, for this particular one, so b would be the number, the plain old number being added here, but we don't have any plain old number here, so we could think of that as being plus 0. And so our intercept is 0, and so it's crossing the y-axis at 0. So that gives us this point 0, 0. And we have our slope of 3/2. So we're going to rise from that point 3. And because we rose, then that means that we need to go to the right 2. And so that gives us a new point on our graph right here. And this is the point 2, 3. So we could think about this slope in another way. We could think about having a slope or a rise that's negative 3. If we think of the rise as negative 3, then our run would have to be negative 2. So then we would, if your rise is negative 3, then you would want to go down 3. And so we'll start at this original point that we had, and we'll go down 3 units. And our run is negative 2, which tells me that I go left 2. And so that gives us another point on our line. And this is the point negative 2, negative 3. And then you can go ahead and draw your line in there and add your arrows onto the ends. So here's another one. F of x equals negative 2x plus 1. So our slope for this one is -2, so it's always going to be that number in front of the x there. And our b, well, I used gray for, we'll try to stick with the same colors. B here is the plain old number, so that's 1, and so it's crossing the y-axis at 1. And so that gives us this point right here at 0, 1. And from that point then we can use our slope to get a couple of other points. So when we think about slope, we always want to think about it as a fraction. And so we can think about this slope of -2 as, oops, I didn't tap hard enough. Let me get my blue. So we could think of the numerator as being -2, and we can draw, or we can write any number as a fraction by writing it over 1. So that would be -2 over 1. Or we could think of the numerator as being a +2, but then our denominator would have to be -1. So either the numerator or the denominator has to be negative when you have a negative slope. So from this original point that we had, we're going to rise -2, that means go down 2. And then we're going to run +1, which means go right 1. And that gives us a new point on our graph. And that new point on our graph is the point 1, -1. So now we'll do the same thing. We're going to go back to our original point, our y-intercept, and we're going to think about the slope in this second way. So +2 for the run means I'm going to go up 2. And then we have a run that's -1, so that tells me to go to the left 1. And right at the end of that then is another point on our graph. And this is the point -1, 3. And once you have 3 points on your graph, you can go ahead and draw that in. And as you see, mine's not exactly perfect, and yours doesn't need to be either, but try to get these as close as you can. In our next example here, we have f of x equals 2x minus 3. And so my slope is always the number in front of x, so my slope this time is 2. We're going to think of that as two different fractions. The first fraction is going to be +2, which is my slope, and I can think of that as being over 1, so 2 over 1. Or we could think about that as being a -2 for our run. But if we have a -2 for a run, then we also need to change the sign of our rise. We also need to change the sign of our run, so that would be -1. So +2 can be thought of as +2 over +1 or -2 over -1. And now our y-intercept, b, is -3. And so this crosses the y-axis at -3. So there's our y-intercept, and that's the point 0, -3. And then from that y-intercept, we're going to use our slope, and we're going to do it in both these ways. So from our point 0, -3, we're going to rise 2, which means go up 2, and then we're going to run 1. And running 1 means that we're going to go to the right 1. And that gives us another point on our graph. And that new point is 1, -1. Now we're going to think about slope as -2 over -1, and we're going to go from our original point here. So -2 as our rise means we're going to go down 2. And then a run of -1 means I'm going to go left 1. And that gives us another point on our graph here, and this is the point -1, -5. And then we can go ahead and draw our graph in. Oops, that's really curvy. And again, it's less than perfect, but that's okay. And we have one more. F of x equals negative 2/3 x minus 4. So the slope for this one is always the number in front of x, so m is negative 2/3. And again, we're going to think of this slope in two different ways. So there are three different ways for you to write a negative fraction. The first way is to write the negative sign in the numerator. So that would give me a rise of negative 2. And then the run would have to be a positive 3. Or we could think of having a rise of positive 2, and then our run would have to be a negative 3. So you can either have the negative sign out front, on top, or on the bottom. One of those three locations for a negative fraction. And our y-intercept, or b, for this one is negative 4. So this crosses the y-axis at negative 4, gives me the point 0, negative 4. And we're going to do our slope in both of these ways. So we're going to rise negative 2. That means that I'm going to go down 2. And then I have to run positive 3, which means go right 3. And that gives me a new point on my graph. And that new point is positive 3, negative 6. And then we're also going to go back to our original point, that y-intercept, and we're going to rise 2. That means go up 2. And then we're going to run negative 3, which means go left 3. And that gives me another point on my graph. And this time the point is negative 3, negative 2. Now that I have 3 points, I can go ahead and draw in our line. Okay, and that ends the lecture on graphing linear functions. If you have any questions, let me know. Thank you.